Here's the solution to number 32. Sorry we couldn't get there in class. Starting off, I will redo A. Recalling that if we have this function, 5x cubed plus 40, which is equal to the definite integral from c to x of f of t dt, according to the second fundamental theorem of calculus, by evaluating the derivative of the left side, 5x cubed plus 40, and evaluating the derivative of the right side, the integral from c to x of f of t dt, we end up with that the derivative of 5x cubed is 15x squared equals the derivative, according to the second fundamental theorem of calculus, would just be f of x. And so f of x is 15x squared. Now, in part B, find the value of c. We want to find the constant here. So we realize that if f of x is 15x squared, and we are told that 5x cubed plus 40 is equal to the definite integral from c to x of f of t dt, well, we could realize that if you take your answer from A and rewrite as f of t would be equal to 15t squared, then really 5x cubed plus 40 is equal to the definite integral from c to x of, well, f of t up here is 15t squared dt. So the integral of 15t squared would be 15t cubed over 3 evaluated from c to x. And that is still equal to 5x cubed plus 40. So now 5x cubed plus 40 would be equal to, now if we evaluate, we're going to plug x in, so 5x cubed minus 5c cubed. So, heading up here, we would have 5x cubed plus 40 equals 5x cubed minus 5c cubed. Well, they both have a 5x cubed, so if we subtract that, those would disappear. 40 equals negative 5c cubed. So now, divide by negative 5. So 40 divided by negative 5 would be negative 8 equals c cubed, and so c would be equal to the cube root of negative 8, which is negative 2. So c must be negative 2.